Good morning, students. Now I'm going to start the class. Today I'm going to revise the second chapter. That second chapter is electrostatic potential and capacitance. This chapter I am going to explain today. Good morning, students. Now I'm going to start the class. Today, electrostatic potential and capacitance. This is our chapter name. Now, first of all, I am going to explain about the potential. Later, we will discuss about the capacitance. If you have any query, write in the chat box. And what is potential? Or the potential difference means what? You learned this one in the 10th class also. What is this potential or the potential difference? Potential difference. Potential difference means what? What is the definition of the potential difference? Can anyone write in the chat box? Okay, I will explain. This is a Q charge. Okay, this is a Q charge. From the around the Q charge, electric field will be produces, right? For example, we are taking some point B, this one, and at the point B there is exists some potential difference, potential, that is VB, and there is some other point I am taking. This is the point A. At point A, I am taking the potential as VA. Potential difference means VB minus VA, potential difference between A and B. If you want to move unit positive charge, for example, I am moving the some Q naught test charge from A to B. For that, I have to do some work. That work done equal to the potential difference. The formula for the potential difference is potential difference between A and B points is VB minus VA is equal to work done to move a charge from A to B by, here we are moving the Q naught charge. This is the formula for the potential difference. Okay, then how to define this potential difference? Why we have to do the work done at here, right? We can take this Q naught as plus 1 coulomb charge, plus 1 coulomb charge. Then the potential difference VB minus VA is equal to the work done to move from A to B. Is it right? Work done to move from A to B. I am taking the Q naught as plus 1 coulomb charge. If you substitute denominator as plus 1 coulomb, WAB by 1 will get WAB, you will get. That means work done equal to potential difference. Work done to move plus 1 coulomb charge. That means the definition is work done to move, work done to move unit positive charge, unit positive charge between two points, between 2 points in electric field. Okay, in electric field is called as, is called as potential difference. Okay, this is the formula for the potential difference and it is the definition. And now, if the potential difference is there, then the charge will move and current flows. That means the current flows due to the potential difference. Our battery will create the potential difference in the circuit to flow the current and charge. And SI unit of the potential difference is what? SI unit of the potential difference. Okay, potential difference is the work by charge. We can write it as joule by coulomb. Work is a joule, charge is the coulomb, work joule per coulomb. Or simply we can also write like this, volt we can write. Its symbol is V. Okay, volt or joule per coulomb is the potential difference formula. Now, what is potential? Potential difference means we are moving the unit positive charge between 2 points in the electric field. You see here, we are taking the charge as 1 coulomb. At the moment, work equal to potential difference, right? I want the definition of the potential now. What is the definition of the potential? Okay, that the potential definition is potential we can write as V. Potential difference also we can write V. And potential means this is the work done. It is the work done to move. It is the work done to move unit positive charge. Same work done. Okay, right? From from infinite to certain point in the electric field. Okay, infinite to certain point in electric field is called as potential. Is called as potential. If you want the potential, okay, you have to take the work done to move from infinite to certain point. I will explain this one also. Okay, how to define this potential. Okay, you see here, previous one is the potential difference, and now the potential is the work done to move a charge. This is for example q charge. This is a source charge. Capital Q is the source charge. Okay, source charge means it can produce the electric field around it. Okay, and here this is a point at P. At this point I want to find out the potential, and then for that what we have to do it here, you have to take the infinite. Okay, this is the infinite point. Okay, and then you have to move the plus 1 coulomb charge, unit positive charge, from infinite to certain point. Then further some work you have to do, right? That work will store in the form of potential. Okay, that work is equal to potential. That means the potential at a point we can define like this, that is the work done to move from infinite to certain point. Okay, at infinite we will take it as, at infinite potential we will take as, at infinite potential we will take as 0. Okay, at point P potential you can consider as V. And now work we are doing to move from infinite to P, right? And then the potential difference formula previously we know, that is VB minus VA. Potential difference formula is VB minus VA is equal to work done to move from B to A by Q. Here Q naught is the test charge. For example, you are moving the Q naught charge. Q naught is the test charge here. Q naught is the test charge. Right? Potential formula is 1 by 4 pi. Sorry. Potential formula is work done. Okay, VB we will take as V at infinite distance. Okay, we are moving from infinite to point P. Then the formula for the potential difference is work done to move from infinite to P by Q naught charge. This is the formula for the potential. Just very simple. Potential difference means it is the work done to move unit positive charge. Q naught you take as the 1 coulomb. Then the potential is equal to work to move from infinite to P. What we are moving from infinite to P? You take the Q naught as unit positive charge. You substitute here potential we are getting as work. Work to move from infinite to P for unit positive charge. Work done to move unit positive charge from infinite to P is equal to potential. If you want to find out the potential at certain point, then you have to calculate the work done to move from infinite to certain point. This is about potential and potential difference. Right? Okay. Let us. I will erase and I will continue the class. If you have any query, write in the chat box. Okay, Twinkle, work done to move unit positive charge between 2 points in the electric field is called as the potential difference. Very good. Okay, and stay in the class, and I will start the important points. And this is the first important question we are going to discuss. That is the potential due to point charge. Potential due to point charge, right? Okay, how to calculate the potential due to point charge? Now, for the purpose, you have to take this as a Q charge. Okay, this is a Q charge, and at point P I want to find out the potential. At point P, I want to find out the potential. That point P is at R distance. Okay. And for that purpose, what you have to do it here, let us take this is the point B and this is point A. Okay. And now this point is at what some x distance it is there. Okay. And now after 1 hour I will come. Now only class start. अभी class शुरू हो गया. मिनिमम कम से कम 40 मिनट लगेगा. बोल दीजिए. Now potential due to point charge we want to calculate. This is the infinite point. Okay, this is the infinite. Okay, and now some I want to move from infinite to certain point P. Further work I have to calculate. Then, for example, at some point this is the some distance dx. At x distance, the potential at x distance, okay, we are taking the some q naught charge. I want to move the q naught charge from A to B. For that I will calculate the work done. Okay, for that I will calculate the work done. And total work means actually potential due to point charge, due to q charge I want to find out the potential. This is a q charge. From the q charge at a distance r I want to find out the potential. Then further what you have to do it here, you have to calculate the work done to move from infinite to P. First small work we will calculate to move from A to B. Later we can do the integration. We will get the total work, right? Because here the electric field is varying. Electric force is varying. Here you can keep the Q naught charge at point A. Then the total work done. I want the work done to move an object from work done to move Q naught charge from infinite to P. That work I want to calculate. The work done formula is, okay, integration. We know formula f of x dx. Okay, this is the formula for the work done. From infinite to P we are moving. P is at what distance? R distance. Then force at a distance x formula we know is according to Coulomb's law 1 by 4 pi epsilon naught into at x distance the force I want between capital Q and Q naught. There is a 1 by 4 pi epsilon naught into capital Q into Q naught by distance is x square we write into dx. Then we have to write here like this capital Q naught by 4 pi epsilon naught is a constant. Okay, one thing you should remember it here. We are applying the force this side, but the electric force this Q naught plus Q naught is repelled by the plus Q. Electric force is right side. That's why here we are writing the applied force work done by the external force to move from infinite to E. Then for that force into displacement is the formula. This force we should write equal to the electric force we have to write. Okay, and then integration infinite to R 1 by x square dx we have to write. Here what I have to did it here, that f of x is the external force that we are applying to move this side. Okay, that is equal to electric force. The electric force formula we know minus Fe. Fe formula is 1 by 4 pi epsilon into capital Q naught by x square. Then we have to simplify it here. Work done to move from infinite to P. Then minus capital Q into Q naught by 4 pi epsilon naught into, there is a formula for the 1 by x square integration, right? That is minus 1 by x. That is integration infinite to R limits. Now minus minus it will become the plus. Use Q into Q naught by 4 pi epsilon naught we will get. Substitute the limits at here 1 by x infinite to R we will get. Now substitute the limits. Q naught by 4 pi epsilon naught into, in place of x upper limit you substitute R, minus in place of x lower limit you substitute, right? And now next 1 by infinite value is Work done to move from infinite to p, we got is 1 by infinite is 0, right? Then 1 by r. Then we will get as final formula as 1 by 4 pi epsilon naught into this capital Q into small q. This one in denominator we write is smaller. This is the work done. Okay, here we got the work done. I want the potential. Okay, potential at point P. Potential at point P. How we can calculate the potential at point P? Potential formula is work done to move from infinite to P by test charge you have to write. Okay, that means now right we can divide this one with small q, q naught, this one not q, it is q naught. Okay, right, that we have divided with the q naught, and finally we will get the formula is 1 by 4 pi epsilon naught into capital Q by r. This is the formula for the potential. At potential at point P, formula we got is 1 by 4 pi epsilon naught into capital Q by r. Okay, now this is the derivation for the potential due to point charge. Okay, right, if you compare this one with the another one, for example, I will write here. You see here, potential due to point charge. Potential due to point charge, what you got? Potential due to point charge. This is a Q charge. This is capital Q charge. At a distance r from capital Q charge, at a distance r, what is the formula for the potential? This is a capital Q charge. From the capital Q charge at a distance r, the potential formula we got is 1 by 4 pi epsilon naught into Q by R, right? This is the formula for the potential. For example, electric field due to potential, electric field due to point charge you want, electric field I want. Okay, how to calculate the electric field? Electric field means, for example, this is a Q charge at a distance R. If you want the electric field, right, at this point electric field I want, then electric field formula is what? 1 by 4 pi epsilon naught into, this is Q by R square we will get, right? Electric field formula is Q by R square. That means here potential is inversely proportional to R, but electric field is inversely proportional to R square. Electric field is inversely proportional to R square. This is extra information in the note. Okay, right. And now I'm going to erase this. I will continue. If you have any query, you write in the chat box, students. Is it clear till now? Now let us go for the next one. Some graph. Okay, that is the potential due to point charge. Potential due to point charge, how it will depends? Potential due to point charge. Potential due to point charge. Right? What is the formula? V is equal to 1 by 4 pi epsilon naught into Q by R. What is Q at here? Source charge. Okay, it does not depends upon the test charge. What is source charge? The charge which can produce the electric field. That is the source charge. Source, it can produce the electric field. Okay, what is our distance of point where we are finding the potential? And electric field due to point charge. Electric field due to point charge. Electric field due to point charge is, electric field due to point charge we got is E is equal to 1 by 4 pi epsilon naught into Q by R square. Same electric field also depends upon distance. Now if we draw the graph and on y-axis we are taking the potential or electric field, on x-axis I am taking the distance, then the graph you will get like this. Okay, for the potential you will get the graph like this. Potential is inversely proportional to R. This is the graph for the potential. Potential is inversely proportional to R. And the second one is the electric field. How electric field depends? The electric field graph will be like this. You will get This is the graph for the electric field. This is electric field is inversely proportional to r square. It will goes down more because it is inversely proportional to r square. This is the graph for the potential difference and electric field. This blue color one is the electric field. For example, we can draw this as red color or otherwise. Sorry, what happening? Okay, for this is for potential. Okay, potential inversely proportional to r. Now, next, potential is a scalar. Okay, potential is a scalar. Potential is a scalar. We should work is a scalar. That's why potential is also scalar. Right? This is about potential due to point charge. I'm going to erase. Potential due to positive charge you take as positive. Potential due to negative charge we should take as negative. Actually, electric field due to positive or negative, for both we have to take positive only, but we have, while adding the them we have to use the vector laws. But potential due to positive charge we have to take as positive. Positive charge is positive, and potential due to negative charge is negative. What is the unit of the potential? Write in the chat box. Okay, let's go for the next topic. Next topic is the potential energy. What is potential energy? Okay, potential due to dipole also we can find out. Okay, potential energy we will go. In the sample paper, this question is there. What is potential energy? Potential energy definition is also similar to that one. Okay, right. Potential energy means it is the work done to move two charges from infinite to certain distance is called as potential energy of system of charges. Potential energy of dipole we learned previously. It is different. This is the potential energy of system of charges. Potential energy of system of charges. Then how to write this one? Just you take here. There is a some q1 charge you take here. Okay, initially this is a q1 charge. I will write this side. This is q1 charge. Okay, and this is q2 charge. Initially they are at infinite distance. Okay, they are at infinite distance. The influence of one charge on another one is not there if they are at infinite distance. Then I am moving these two charges nearer to each other. Instead of moving one also you can move. Okay, we can move q2 charge from here to here, some point p. This is a, this is b, this is infinite. I want to move the q2 charge from infinite to b point. Okay, right, I want to move the q2 charge from infinite to b point. Then further work we have to do. That work will store in the form of potential energy. There exists some potential energy between these 2 points, two charges. Okay, right. Then what is the potential energy of system of charges? Why potential energy is there? Because for example, if these two are the like charges, if they are kept at some distance at here, then if you release them due to the repulsion force, they will fly away from each other. That means they are flying means they have the attain the kinetic energy after leaving. They having the kinetic energy means when they are kept at this location, they have the potential energy. That potential energy due to repulsion force between them, that potential energy convert into kinetic energy, right? And now here work done we have to calculate to move q2 charge from infinite to this point. Then work done we know that due to q1 charge potential we have to find out. Okay, expression I am going to derive, very easy expression. Potential at point B Q2 Q2 charge, sorry, due to Q1 charge. Okay, what is the potential at point B due to Q1 charge? That is the potential formula. Just now we derived potential due to point charge 1 by 4 pi epsilon naught into Q1 by R due to Q1 charge. Okay, for example, this is the Q1 charge, and from the Q1 charge at R distance, if you want the potential, that potential formula is 1 by 4 pi epsilon naught into q1 by r. This is the formula. Just now we derived potential due to point charge. 1 by 4 pi epsilon naught q1 by r. This is the potential formula. I want the work done to move q2 charge from infinite to point B. Okay. At point B, we got the potential V. Right. Work done to move. Work done to move q2 charge from infinite to B, from infinite to point B. What is the work done for that? Can you tell work done? Then we know work done formula is, previously we discussed the potential formula. Potential formula is work done by test charge that we are moving from infinite to some point, right? Test charge. This is not source charge. Okay. Then we will take like this Q naught. But here the test charge is Q2. That's why work done we will get as V into Q naught. Potential is V, but we are moving Q2 charge. That's why work done equal potential into Q2 charge. Then work one is potential is what here from above equation 1 by 4 pi epsilon naught into Q1 by R into Q2. Then finally we got the work done formula as 1 by 4 pi epsilon naught into Q1 Q2 by R. This work will store in the form of potential energy, right? Okay, then if you release that charges, then they will go away with this potential energy. The potential energy formula is 1 by 4 pi epsilon naught into q1 q2 by r. This is the formula for the potential energy of system of charges. Don't confuse with the potential energy of electric dipole and potential energy of system of charges. This is the expression for the potential energy of system of charges. If two charges q1 q2 are separated by certain distance, right? This is the potential energy of system of charges. System of charges. If two charges are there, then between them potential energy is this one. Previously in the last chapter we derived the potential energy of electric dipole. That is different. Okay, right? This is the potential energy formula. Potential energy of two charges in vacuum. This one potential energy of two charges, these are not in the electric field. Okay, and now if the system of charges are, if many charges are there, then how to find out the potential energy? I'm going to erase this. If you have any query, write in the chat box. Students, till now is it clear? Is it clear? Okay, right, let us go for the next continuation. If you want the potential energy of system of charges, so we can write, for example, there are so many charges are there. Okay, potential energy of potential energy of potential energy of a system. Okay, potential energy of a system of charges. If more than two charges are there, then how to find out the potential energy of charges? Okay, for example, you see here very simple it is. This is a We will take the three charges at here. Okay, this is Q1 charge at here, Q2 charge at here, Q3 charge at here. For this potential energy, if we want to find out, then how many combinations it will comes at here? This distance is R12 and this distance is R23 and this distance is R13, R12. This distance we will take as R31. Okay, right? Potential energy of this system we want to calculate. Okay, for that, work done to move Q1 charge, work done to move Q2 charge, work done to move Q3 charge, we can find out. Okay, it was very simple. Then first of all, for example, the Q3 charge is at here, Q3 charge is already at here. Okay, we are moving the Q1 charge from infinite distance to some point here, and we are moving the Q2 charge also from infinite distance to here. Then for this work done, we have to calculate work done to move. Initially, this Q1, Q2, Q3 are at infinite distance. This distance is infinite. This distance is infinite. Okay, and now we are moving from infinite to this point. Okay, and this Q2 charge also we are moving from infinite to this point. At the moment they will come to finite distance, and we have to find out the potential energy. Very simple it is. I will explain very easily. For example, Q3 charge is already presented here. Q3 charge is already presented here. Then work done to move due to Q3 charge. Due to Q3 charge, the potential at point Q1 is okay. Potential this A, B, C we will take. Potential at A due to Q3 charge. What is the formula? Yes, that is 1 by 4 pi epsilon naught into. Yes, we write as Q3 due to Q3 charge. Q3 by R31 we have to write. And next, work done. This is V1 we can consider. Work done to move Q1 charge from infinite to A point. Okay, how much work we have to do to move Q1 charge from infinite to this is the Q1 charge. Oh, this is the Q1 charge. Q1 charge, we are moving from infinite to this point. Then how much work we have to do it here? That work done, this is at infinite distance. Infinite to here we are moving. Then work done formula. Then very simple it is the work done, how we can calculate potential into moved charge. We are moving the Q1 charge. Then 1 by 4 pi epsilon naught into 1 by 4 pi epsilon naught into Q1 by potential into moving charge. Potential is V1. 1 by 4 pi epsilon naught into what is the V1? V1 is a 1 by 4 pi epsilon naught into Q3 by R31 into Q1 we have to write. Okay. Then we will get as 1 by 4 pi epsilon naught into Q1 Q3 by R31 or R13 we can write. Okay. This is W1. Next we have to move the Q2 charge from infinite to some point. Okay. For example, the Q2 charge is initially at infinite distance. Okay. Q2 charge is at infinite distance initially. Then the Q2 charge we are moving from here to here. Then we have to calculate the work done. For the purpose, potential at A we have to calculate. Potential at B, we want to move to up to point B. That's where we have to calculate the potential at point B. We are moving the Q2 charge from infinite to point P. Work done to assemble the charges as shown in the figure, that is called as potential energy. Then potential we require potential at B. At potential at B is due to what and what it will be there. Potential at B is due to Q1 charge it will be there. That is what 1 by 4 pi epsilon naught into Q1 by R12 we have tried. And due to Q3 charge also there, right? 1 by 4 pi epsilon naught into Q3 by R23 we write. Q3 by R23 we have tried. Okay. And here we got potential. Why here previously Q1 is at infinite distance, Q2 is at infinite distance. Due to only Q3 is there. Due to Q3 we wrote the potential at A. That is only this one. But next Q1 we brought to here, right? Now Q1 is there, Q3 is there. Now we are bringing the Q2. That's where potential at B is due to Q1 and Q3 also there. Due to Q1 means Q1 1 by 4 pi epsilon naught Q1 by Q1 distance we have to take from B. Due to Q3 means 1 by 4 pi epsilon naught into Q3 by Q3 distance you have to take, right? This is the potential. Then next we have to calculate the work done. What we have to do? We have to calculate the work done to move Q2 charge from infinite to B, right? Then this work will equal to potential into charge. Potential at Q2 is V2, potential at Q1 is V1, right? V2 into we are moving the charge Q2, that's why V2 into Q2, this is W2. And V2 formula is this one, right? 1 by 4 pi epsilon naught into Q1 by R12 plus 1 by 4 pi epsilon naught into Q3 by R23 we have to write into what we have to do it here, Q2 we have to write. Then finally we are getting the formula 1 by 4 pi epsilon naught into Q1 Q2 by R12 plus 1 by 4 pi epsilon naught into Q1 Q3 Q2 Q3 Q2 Q3 by R23. Just you have to multiply with Q2 at here on. Okay. Right. This here we got the W1 work. Here we got the W2 work. Then what we have to do? We can take these two as the equation 1 and 2. Then we have to add both of them. We will get the total work done. Okay. The total work done we will get like this. That is the just it was very simple. I will write in the left side. Total work, right? That is the W equal to W1 plus W2. Then the W is the 1 by 4 pi epsilon naught into Q1 Q2 by R12 Q1 Q3 we got here. W2 formula is this one. We combine all of them. Okay, right. 1 by 4 pi epsilon naught q1 q3 by r31 plus 1 by 4 pi epsilon naught q1 q2 by r12 plus 1 by 4 pi epsilon naught q2 q3 by r23. This is the formula for the potential energy, right? What is the work? This work equal to potential energy. Work is equal to potential energy, that is U. Then the potential energy formula is 1 by 4 pi epsilon naught. We will rearrange them. Q1 Q2 by R12 plus 1 by 4 pi epsilon naught into Q2 Q3 by R23 plus 1 by 4 pi epsilon naught into Q3 Q1 by R31 we have tried. This is the final formula for the potential energy, right? Potential energy of system of charges. It was very easy to remember, right? It was very easy to remember. How? Potential energy between these two charges, 1 by 4 by epsilon. Between two charges we derived, na? 1 by 4 by epsilon Q1 Q2 by R12. Between two charges, 1 by 4 by epsilon Q2 Q3 by R23. Between these two charges, 1 by 4 by epsilon Q3 Q1 by R31. Right? Simple. Then sum of between these two charges, potential energy will be there. The three potential energies you have to add, then we will get the total potential energy. It is very simple. Understood, students? Is it clear? Is it clear? Whether clearly appearing or not? Okay. Let us see. Let us continue now. I'm going to erase this. Next one is the potential energy of this is there in the uh, very important sample paper. It is there in the sample paper of 2021. Potential energy of system of charges in electric field. In electric field. Okay, we have to find out the potential energy of system of charges in electric field. How to calculate this? Right? How to calculate the potential energy of system of charges in electric field? Okay, electric field means right. Our topic is the potential energy of system of charges in electric field. You see here, this is an electric field. Electric field we are applying the right side. Okay. Then due to electric field at this potential is V1. At this potential is V2. Okay. Right. In the electric field potential is there at certain points. This electric field is produced by some external, okay, external agent. Some charge is there here, some positive charge is there, here some negative charge is there. Then in this electric field we have to bring the two charges. One charge we have to bring to this position, other charge we have to bring to this position. For that, then we have to do some work. That work will store in the form of potential energy, right? This distance we will take as r. Previously, if there is no electric field, if there is no external electric field, we derived the formula for the potential energy. But now here we are keeping the potential energy, two charges in the electric field. Then what is the potential energy? Then for the purpose, what we have to do it here? Okay, look at here very carefully. First, we have to bring the Q1 charge from infinite to this point. Work done. This point we can take as A, this point we can take as B. Work done to move Q1 charge from infinite to A. How much work we have to do? Yes, previously Q2 is not there. Just we are bringing the Q1 at here. The further work done is potential V1 into Q1. Okay, the work done equal to potential into Q1. This is equation 1. Then next, we have to move the work done to move Q2 charge. Now we are bringing the Q2 charge. Q2 charge from infinite to B. Then that work done is the potential into charge. What is the potential at Q2? At potential at Q2 is V2 due to electric field, right? That is V2 into Q2. That is due to electric field. The total potential I want. Potential due to electric field is V2, okay? But potential due to Q1 also there. That is because we Q1 just now we brought. First Q1 we got, okay? At the moment Q2 is not there. That's why we're going to write is only potential due to electric field into charge we wrote. But now we are bringing the Q2 charge. Q1 already we brought. That's why due to Q1 potential will be there at point Q2, and due to electric field also potential is there. V1, V2 are what? V1, V2 are potentials at points A and B due to electric field. They are the potentials due to electric field, not due to other charges, right? Due to electric field, due to external electric field. And now the question thing is that here we want to calculate the work done to bring the Q2 charge, work done to bring the Q1 charge we got, work done to bring the Q2 charge we want. Then that work done is the 1 by 4 pi epsilon naught into 1 by 4 pi epsilon naught. Potential due to electric field is V2, potential due to Q1 charge also there. That is Q1 by distance is R, right? This is the total potential. Potential into what we have to do it here? Potential into charge. Charge we are moving is Q2. This is equation 2. And then we have to simplify this. And we will get is V2 Q2 plus 1 by 4 pi epsilon naught into Q1 Q2 by R we will get. This is equation 2. Then the total work is equal to potential energy. That is the total work we have to add both of them. That is the W1 plus W2, right? Then we will get is V1 Q1 plus V2 Q2 plus 1 by 4 pi epsilon naught into Q1 Q2 by R. This is the total work done. And potential energy of system of two charges. Potential energy is equal to work. That formula is V1 Q1 plus V2 Q2 plus 1 by 4 pi epsilon naught into Q1 Q2 by R. This is the formula for the potential energy of system of charges in electric field. Okay, right. And look at here, work done to bring the Q1. Actually, previously we derived potential energy to assemble the Q1 Q2 charges at R distance. Only this formula we got, but here extra we got this one. Why this extra we got? Extra due to electric field potentials V1 and V2. Further work done will be there. Work done where the potential is there, there the work will be there. If, if there is no electric field, V1 V2 becomes 0. This will 0. This will be 0. Then the potential energy will become only 1 by 4 pi epsilon Q1 Q2 by R. If external electric field is 0, okay, if external electric field is 0, okay, then what you will get the formula? If external electric field is 0, if ex- external electric field, if external electric field is 0, then V1 and V2 become 0, right? When V1 and V2 become 0, then the potential energy what you will get? Potential energy of system of two charges you will get is only 1 by 4 pi epsilon Q1 Q2 by R, just similar to previous formula. Understood? Right. Any query, students? Any query? Write in the chat box. If you have any query, write in the chat box. If you have any query, write in the chat box. Otherwise, we will continue. Clear, students? Is it clear? Is it clear? Somewhat difficult it is there in understanding, but once again you can hear to understand. Okay, we will start the next capacitor concept. Okay, at very important than these potentials. Capacitor concept I am going to start. That is very important, very important for the board exam. Okay, right. Let us start. Next, first important question is that capacitance. Capacitance of parallel plate capacitor. Uh, Before going to that, I will explain one more formula. It is the relation between electric field and potential. Relation between electric field and potential. This I have to derive. After that, we will go for the capacitance. Okay, right? Relation between electric field and potential. What is the relation between electric field and potential? Let us take this as a capital Q charge. Okay, source charge. From the source charge, we will take the 2 points. This point we will take as B, it is at less distance. This point, this is plus Q charge you take. Okay, and this point is at R1 distance, and this point is at R2 distance. When the distance is increases, the potential decreases. Is it right? Because potential is inversely proportional to R. And here at point B, the potential is VB. We can consider at point A, the potential is considered as VA. Okay, right. This the distance between these 2 points we will take as a dr, and we will consider that the VB is equal to some V plus dV, and VA is V considered. Why we are taking VB is more by some value, right? The potential difference between 2 points, potential difference, potential difference formula is potential difference between 2 points. We are moving, for example, we are moving some Q naught charge from A to B, right? Then for that some work we have to do, is it right? Work to move from A to B, and the work here electric force will act this side. This is a plus Q naught charge we are moving, and when electric force, this plus Q repels the this side. This side electric force will act. Electric field will be there. Okay, electric field is the right side at here in this figure. Electric field is right side, and electric force also right side it will be there. Then we are moving the charge from here to here through dr distance. Then for that, how much work we have to do? Potential difference between 2 points, that is potential difference is equal to VB minus VA. We are moving from A to B, A to B. Then work done to move from A to B, work done to move from A to B by test charge. This is the formula previously we discussed, right? Potential difference is from the figure we write here like this. That is a V plus dV minus VA is we write as point here, potential we are taking as V. When you will go from A to B, the potential is increased by dV. Why it is increasing? Because distance is decreasing. Now when you will go this side, distance is decreasing because the potential is inversely proportional to R. Na? Potential is inversely proportional to R. At B point, this is B point we take, or this is we take A point. At A point, the distance is more, that's where potential is less. At A B point, distance is less, that's where potential is less. Where capital Q is the source charge, okay, source charge. Potential depends upon the source charge only. And Q naught is the test charge. Q naught is the test charge. Now, potential difference formula is work done to move from A to B. Work done to move from A to B formula we write is force into displacement. Okay, force into displacement. We write as force into displacement. We are taking as dr. Okay, by F bar dot dr bar we will take by Q naught. Then the force is equal to we write as electric force. This we write as dV is equal to force formula we write as force on Q charge in the electric field we write as force is equal to minus of electric force we write. Electric force formula is E into Q. Q naught is the test charge. force on Q naught charge placed in the electric field. Q charge can generate the electric field. Q naught we placed in the electric field. On that Q naught force will act. Force on Q naught is E Q naught equal to F B Q naught. F by Q naught, F equal to E Q naught. Then we write as here minus E Q naught into dr by Q naught. This Q naught cancel. And finally, we are getting the dV is equal to minus E bar dot dr bar. Okay. At this, we can also write as dV is equal to minus EdR cos theta. And if theta is parallel, if dr and if E bar parallel to dr bar, dr is a displacement. Okay, electric field displacements are parallel. Then we take theta as 0. Then we will get dV is equal to minus EdR, and E is equal to, we will get as minus dV by dr. This is the final formula. It is the relation between the electric field and potential. Electric field, what is the meaning of this one? E is equal to minus dV by dr. dV is the change in potential, dr is the distance, E is the electric field. Electric field is in the direction of decrease in potential. In which direction the potential is decreasing? In the direction electric field will be there. In the direction of decrease in potential. Okay, electric field is in the direction of decrease in potential. In which direction electric field is decreasing? In the direction, in which direction potential is decreasing? In the direction electric field will be there. Okay, electric field is equal to negative. Negative means decrease. Electric field is in the direction of decrease in, this is what, potential by distance. Okay, right. Let us go for the next topic. Next, very important topic we are going to discuss. More 20 minutes I will continue. If you have the patience, you can hear. Okay, next one is the capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor, very important. What is a capacitance? What is a capacitor? Capacitor is a device, it is used to store the charge. Capacitor is a device used to store the charge. Capacitance of parallel plate capacitor. How to find out the capacitance of parallel plate capacitor? Okay. Capacitance basic formula, anyone write in the chat box? What is the formula for the capacitance? What is the formula for the capacitance? What is the formula for the capacitance? Write in the chat box, students. Write in the chat box. Do it fast.